Okay, so I'm still probably right about a week from being completely ready to fire back up and get back to my normal stuff. But I'm almost there, and I wanted to kind of go over this just for the sake of an update. Hopefully next week will everything will be turned back on and working the way it's supposed to. Going over the setup, I think that this is the arrangement that I like, and this isn't changing. I've got my 5 inputs coming on in up here, and I've got it set up to where I can disconnect the turbines real easily. That's the whole point of having those particular plugs. I am going to come back and I'm going to label these just so that it's labeled that they're not, proper outlets, but they have worked for me for about a year. I'm going to try to do a little bit with this stuff to make it look a little bit tidier, but that's mostly how that's going to stay. And the first big thing that's changed here is this, my rectifiers. And what I've done is I have put them on an aluminum channel. Now the rectifiers, they all have good heat sinks on them already, so them dealing with the heat themselves is not really a problem. They can get pretty warm, but I have had that one up around 400 degrees Fahrenheit, and previously I had it mounted excuse me, on this wooden panel, which catches on fire right around 450. So don't want to have that happen. So now I've got them set off of the wooden panel, and then on top of that there is a 1.5-inch hole cut behind each one of these. And whenever things start getting real warm, this fan will come on, and I've got this set up. I'm going to play with it one way or the other, see what works best. But right now it's set up to pull through the channel. So it should be pulling air through all the fins into the channel out over here. And I'm hoping that will help keep things cooler. The relay pack that's here, now I don't have this set up just yet because I've actually got to, I'm going to go and get some cord caps like these so I can run with number 10 wire and change the angle a little bit. And these are going to come over to these relays. I have one lead here, one lead here, one lead here, and then a jumper from here to that one. Whenever this gets over 60 volts, it's going to turn these relays on, and that's going to effectively be my brake. It's going to be automatic. That way, if I have a relay fail downstream, it will turn that on. I could just use cord, a cord in like I've got here, and I may do that temporarily until I can get the cord caps in. But those, they've only got 12 gauge at the most. I need 10 gauge at the very least to run to those relays. I'm going to have this relay pack run to this turbine and this turbine. This is the Healy 2.0. This is what I have the i1500 going to, and both of those turbines I have seen kick out some very serious amperage. So I want the brakes on those. The other turbines are not that powerful, so even if something fails, they're not likely to damage something quite so significantly as the two big ones. Now this is the next thing it hasn't changed much. I did end up running heavy cables from my battery packs to this set of terminals. I keep trying to touch those, but they're hot. And also up here. Now, and I described this in the last video, is that these three circuits are now dedicated 48 volts. They're always going to be 48 volts. This one right here is 24 volts. That one, the number 4 position and the number 6 position have not been filled yet, and I'm kind of leaving those empty to where I can hook up my 24 volt and 12 volt systems whenever necessary. But probably not going to be very necessary very often. I'm going to try and stick to running just 48 volts. This is the next arrangement that has changed. Now I'm still using these cheap micro inverters. I would like to get away from these things, but I can't find anything else that actually operates at the voltage that these things run at, and also has the safeties that these things have. They're not very reliable, but I'm having a hard time finding alternatives. If you guys know of a product that will operate in the, like I have them all set up running as though they're 24 volt circuits. I need something that's going to operate from 24 to 32 volts. If you know of an inverter that will fill that role, then I'd love to hear about it. So, but what has changed here is something that I was doing often is I was burning up those Photech relays. And I have actually made a video about that. The Photech relays are not themselves reliable. I do have some other ones because those happen to be in the box. I've still got half a dozen Photechs that I'm going to burn through before I do get rid of them. Now, one of the things to keep in mind about the Photech relays, what burns them up really often is if, of course, my camera's upside down. Let's flip it over. That 3 to 32 volt DC, that's important. If you exceed that 32 volts, then they get real, that switch burns up. And that's one of the things that really takes them out, and it takes them out very quickly. With like these other ones, these Omcon, or I don't know if that's Omcon, because I think that's a Q. I don't know who made those. They were, something I was able to get in bulk, cheap, but they seem to be made a lot better. I can run a lot more voltage to those things, and they're not burning up. But those Photechs are burning up almost straight away. Now, I had that happening, and then whenever I had a lot of amperage going through them, they'd also get real hot then. As like previously, I had them mounted on heat sinks similar to this. Much bigger than this one, but very similar. These were computer processor heat sinks. And they weren't really cutting it. So now I have those also mounted on the same aluminum channel. It's got a nice clean surface on the other side. On the inside of this channel, I have also mounted multiple processor heat sinks, the same things that I was running before. So hopefully this 1/4-inch plate that the channel's made out of, that will draw a lot of heat. Those heat sinks on the inside will draw a lot of heat. And then, on top of that, I have this set up so that anytime that this relay and this relay, whenever these two relays come on, it also runs power up to this little inverter that will convert, man, I cannot keep my words straight. This will convert 24 volt down to 12 volt. Turn this fan on. The switch, that's also what turns that fan on. So anytime that, if all of the inverters are going, which should be most of the time, if all of the inverters are going, then the fans are going to be running, which should help keep that channel and the my relays and those diodes a lot cooler. The way I have this set up is I got them set up to come on at slightly different voltages. So this one operates this relay and this relay, and it's going to come on at 26.9 volts. This switch operates this relay and comes on at 27.9 volts. That what I'm hoping is that there will be a little bit of a cushion there so that it doesn't just slam the entire load onto the system and just stop my turbines. I'm actually going to try and maybe run that one a little bit higher, maybe 28.2, something like that. And then whenever this one comes on, whenever the heavier load comes on, I'm going to turn this down just to demonstrate it. Whenever the heavier load comes on, that's whenever the fans come on. Let's cycle through this. Right now I have it set for 21.9. Whenever it's at 21.9, this is also draw through. It's drawing air through the channel, through those heat sinks on the inside. It is open over here. And I can actually, I can feel a really good draft on this side. Same thing up here. That's drafting through. I did try running this one backwards just to see, how much air it's moving. It's actually moving a pretty good bit of air. And I debated doing that, but my thinking is that because the fins are horizontal and it's open on the back, basically the air, whenever it comes out, if I set this to push into the channel and then out this way, all that hot air is going to come out and hit the diode next to it. If it goes in, then it's all, there's going to be hot air on the inside, but it's not going to use any of these diodes to warm up any of the other diodes. And then drawing through out here is the only way I can think of that this would really work at all. And let's turn that back up. And I think that I am going to do it at 28.5. So that side will come on at 28.5. This side comes on at 27 or 26.9. And then up here, this is basically set to turn these switches on at 60 volts. And I have this set up to where these are all, this is the same thing. The switching voltage is 3 to 32 volts. And I've got that set up to where they're in parallel, so hopefully it's only, whenever this comes on, it's only going to be hitting them with like 30 volts each. I don't know if that'll really work, but I have tested it even at 60 volts and they didn't burn up, so maybe they'll be okay. We'll find out. Or I might get another little, thingy like that and run it off of that thing. I'm not 100% sure yet, but I do know that I want this switch to run off of total voltage coming off of the full battery load. So then, the last thing that's really changed is all of the inverters are now hardwired. This is the last configuration. I can't, with this setup, maximum possible potential is 5,000 watts. And that is if I can hit each of these things with, 40 amps a piece? It's not very likely, but, assuming that happens, I guess closer to 30 amps if we're running closer to 30 volts whenever the system shuts down. Anyway, maximum possible potential is 5,000 watts, and my shop is separated from the grid. The wire run is long enough and it's small enough that I can't possibly deal with more than 5,000 watts. Not without upgrading a lot of other stuff, which might do over time. So, those are all hardwired. Junctions are in those boxes. I do have this inverter over here. This is going to be for other tests if I'm running a test turbine, something like that. It's not even currently hooked up because I don't know which side I'll be running it to. It is wired into everything else, but not active. Then all that goes back up into the whole switch assembly like I've always had it. Up here, I'm going to have 2 meters similar to this, but reading AC current, just so I can see what's being pumped back, instead of having to use a meter like this that I have to run a 12 gauge plug to. So that's that. It's a little bit of an update. Like I said, it's not quite running yet. I am hoping that by next weekend, I'll actually have it up and running and things going good. So, thanks for watching, guys. I hope you all have a wonderful evening. And those of you who need it, I hope that you stay safe. Good night.